students, today we are going to discuss the remaining question from JEE Mains 2026 21st January evening shift remaining questions. Let us check. Okay, now the first question. Which of the following statement is correct? Nucleotide containing 1,4 linkage. Quaternary structures of protein is compact folded structure. And the third one, during denaturation of protein, secondary and tertiary structure destroyed and primary structure retained. The fourth one, enthalpy of enzymatic hydrolysis of sucrose is greater than acid catalyzed hydrolysis of sucrose. Right now here in this point, nucleotide containing 1,4 linkage. See, nucleotide, it is nucleic acid, RNA, DNA, RNA, that is based on that nucleic acid. Now the linkage is actually, it is 3,5 phosphodiester. Actually, it is not 1,4 linkages. It is 3,5 phosphodiester. Diesters. Right, so this is totally wrong. And the quaternary structures of protein is compact folded structure. Yes, it is correct. During denaturation of protein, secondary and tertiary structures destroyed and primary structures retained. So this also correct. This question, it is based on biomolecules in that protein nucleic acids. That point it has mentioned. And then enthalpy of enzyme, even enzyme also, it is biomolecules chapter. In that everything it is available. So the first question, 15th question, it is based on that biomolecules part. Okay, so enthalpy of enzymatic hydrolysis of sucrose is greater than acid catalyzed hydrolysis of sucrose. This is totally wrong. You know, the first and the fourth, it is wrong. You know why? Enzymatic hydrolysis delta H, it is catalyzed by hydrolysis only. So here enzymatic hydrolysis of sucrose is equal to acid catalyzed hydrolysis. Both are equal, right? Enzymatic hydrolysis of sucrose is equivalent to acid catalyzed hydrolysis of sucrose. So it is not like a greater than or lesser than, it is equivalent. So E and D, it's wrong. B and C, it is correct. So B and C, that what is this? Option 2, it is correct. Hope you got the clarity. Come on, let us go to the next question. The next question, find correct order of rate of reaction of CH3Br with given nucleophiles. So, which is the stronger nucleophile, the strength of nucleophile more? Let us check the order. Okay, now here, generally, the rate of reaction of SN2, CH3Br, it is no, CH3Br they have given. So, CH3Br, it is SN2 reaction. So, the rate of reaction CH3Br with the nucleophile depends on the strength of the nucleophile. So strength of the nucleophile, how do we identify? Stronger the nucleophile, faster the rate of reaction. So which is the stronger of the nucleophile? Stronger the nucleophile. What it is? Faster the rate of reaction. Faster the rate of reaction. So this is very important. So in that among OH, generally it is OH, what it is, strong base, KOH, NO, NaOH, no? So that is OH, it is very strong base, right? Now next one, PHO. So PHO, it is phenoxide. So phenoxide, it is phenol, it is actually lesser than phenoxide, it is more stronger. So phenoxide, because it is due to resonance. Okay, so resonance stabilized. Right, next one, what it is? Here, HCOO minus. So HCOO minus, it is overall weaker base. This is actually what it is. This is overall weaker base. Right, now next one, what it is? ClO4 minus chloride. So that means this is highly resonance stabilized due to that presence of multiple oxygen atoms and conjugate base. Okay, so here what it is? Highly resonance. Here also highly resonance. Right, now resonance stabilized, and due to that presence of multiple oxygen atom. Reason what it is? Presence of multiple oxygen atom. Right, now, so that means based on the strength of nucleophile, more stable anion is less nucleophile. Okay, so here according to that, this is actually conjugate base. Right, now in that OH PHO. Okay, so OH PHO, HCOO minus and chlorate. That is, so option A is the correct option. Hope you got that clarity. As you have learned a number of times, you have gone through this point and this topic also. I think you got that idea. Come on, let's go to the next question. The next question, statement 1. There is 2 sp3, 1 sp2 and 1 sp hybridized carbon present in this compound, the first compound. Here, that bond line structure, no, here actually what it is? sp3, right? This is sp3 because CH3, CH2, here CH, double bond C, double bond O. Okay, so this is actually what it is, sp3 hybridized only. This is sp3 hybridized, sp3. And the next one, this also sp3 only. And then this is double bond which is connected, no, sp2. And the next one here, both the side double bond, no, this is sp. So what they mentioned in the first statement, 2 sp3, this is 2 sp3 and 1 sp2 and 1 sp. The statement, it is 100% correct only. The statement, first statement, it is 100% correct. And the second statement, what it is here, Br, benzene, which is connected, C double bond O, which is connected with pentanol, right? So this is a chiral center. How many chiral center it is there? 2 chiral center. So 2 chiral center means, chiral means what it is? 4 different groups or atoms attached to that carbon. That is called chiral carbon. So this is the chiral carbon. Okay. So that means this point, it is a chiral. So 4 different groups or atoms attached to that. In that hydrogen one is there, and then OH, this side one, and this side, both are, all are different. So this is one chiral center. And the same way, this side also one chiral center is there. So here one and here one, here CH it is there, and C double bond O. So this also 2 chiral center, 100% 2 chiral center it is there. So what it is, both the statement actually it is correct only. So both the statement it is correct. So here what is the correct option? Statement 1 is correct, statement 2, both the statements are correct. Option 3 is the correct option. Hope you got the clarity. This is very simple. And what is that concept? According to that, you have got it right. Okay, now come on, let's go to the next question. 1 gram of unknown organic compound produce 1.49 of Mg2P2O4. Determine percentage of phosphorus in unknown organic compound. This is very simple. Percentage, finding out the percentage, no, it's very simple. Okay, phosphorus only they are asking. So percentage of phosphorus. Percentage of phosphorus. What is the formula for it? That is number of moles. Number of moles of this compound into number of atoms. Number of atoms. How many numbers it is there in the present in that compound into atomic mass of that atom. Atomic mass of that atom. Okay. So phosphorus only they are asking, divided by given unknown organic compound. No, that is given mass. Given mass of organic compound. Organic compound. That's all. If you apply, no, you will get that complete idea. So number of moles of what it is, Mg2P2O7. So that is given mass by molecular mass. So given mass 1. What it is, 49 they have given. No, so this is actually 1.49 divided by molecular mass. This is actually what it is, Mg2P2O7. So Mg2P2O7, what it is actually here, Mg2. Now what it is, Mg2, it is 24 into 2 plus 31 into 2 plus what it is, so 16 into 7. So altogether you will be getting what it is, around 222, yes, gram per mole, right? Into number of atoms, it is 2, into atomic mass of phosphorus, it is 31, divided by what it is, organic mass of organic compound, it is 1 gram. Right now this is completely, I will write it here, 149, 1.49 divided by 222 into 2 into 31 divided by 1. So when you calculate this all, okay, so this 221 will come down. So naturally, so here when you calculate this point, here 62, no, so 1.49 into 62 divided by 222. So you will get around what it is, 923.8 divided by 222. So you'll be getting around 41.6 percentage. Okay, 41.6 percentage of phosphorus only they are asking now. So 41.6 percentage. Come on, let us check the answer whether it is correct or not. So yes, there is Okay, 41.6 percentage it is available. So option 4 is the correct option. See, that is what, when you are reading the question only, you just take down the concept of what you have learned and practiced. So just to bring that point and apply the value. First, you collect the data so that it will be easy for you. First thing, concept. The second thing, applying the value according to that concept. And third thing, you will get the answer. Come on, next. The next question. In the following 4 molecules, one is optically active and find the percentage of carbon in chiral compound. Okay, so here first and foremost, chiral compound is eligible for that optically active, right? And percentage of carbon we have to identify in that compound, which compound is having chiral carbon, that means optically active, no, for that. Okay, now let us identify which one is having chiral carbon. The first one, what it is here, 1 chlorobutane, 2 chloropropane, 2 chlorobutane, 1 chloro, 2 dimethyl propane. Okay, the first one, CH3, CH2, CH2, 3, CH2Cl, 1 chlorobutane, and the second one, what it is, 2 chloropropane, CH3 here, CH3, CH2, yeah, CHCl, CH3. So 2 chloropropane, and the third one, what it is, 2 chlorobutane. So this is CH3, CHCl, CH2, CH3, and the fourth one, 1 chloro, 2 dimethyl propane. Okay, CH3 neopentane, like, okay, C here, CH3, CH3, CH2Cl, 1 chloro, 2 dimethyl propane. Right. So in that, which is having a chiral carbon, we have to identify. Okay. Now this carbon, now here there is no chiral carbon at all. And then here it is a CH. Here actually both are 2. Okay. Now there is no equal. That means same atom or molecule is available. Means there is no chiral carbon. And whereas here one side hydrogen, one side what it is, chlorine, the other 2 sides methyl and ethyl. Yes, this is a chiral compound. Okay, so chiral carbon is what it is for. Different groups or atoms attached to that carbon, that is called chiral carbon. So this is 100% chiral carbon. Okay, now this is actually what it is, CH2Cl. Actually, here you cannot identify because it is the same group or atom, right? So this also. So which is a chiral carbon? This 2-chlorobutane only is the chiral carbon. Now 2-chlorobutane, it is 100% optically active. Yes, because it is a chiral is present. So optically active. Right. Now the next one, and it is a chiral molecule. 100% it's a chiral carbon. Chiral molecule. Okay, now next one, molecular formula. This is that molecular formula. So what is that molecular formula? C4H9Cl. Okay. 3, 4, 5, and 8, 9, and Cl. Hydrogen. Yeah. 4 carbon, 9 hydrogen, and 1 chlorine. Right now, molecular mass. This is a molecular formula. Molecular mass, it is 12 into 4 plus 9 into 1. Okay, 9 plus chlorine, what it is, 35.5. So altogether 92.5 gram per mole. Right. Now percentage. Already I have given that idea how to identify the percentage composition. How to identify. So percentage of carbon. So percentage of carbon is equal to, here what it is, 48. See, carbon, how much it is? 12 into 4, it is 48. No. So given mass by molecular mass. No. So 48 divided by 92.5. Right. So 92.5. So given mass by molecular mass, not like that way. Here, what is the mass of that carbon over here in this molecule divided by whole present in that. Okay. So you will get that percentage into 100. That is into 100. Into 100. Always percentage means 100, it is mandatory. So 51.8 percentage. Yeah, I hope you got the clarity. See how the way the question they are asking, seriously, it is really interesting. Okay, so which is the correct option? Option 3 is the correct option. 51.8 actually. Yes, it is correct. Hope you got the clarity. Come on, let us go to the next question. Among the following, vanadium 3 plus, titanium 2 plus, nickel 2 plus, iron 2 plus, and cobalt 2 plus, for which spin only magnetic moment it's greater than 3, and which can form high spin octahedral complexes. Find the sum of unpaired electrons in those complexes. It's really interesting and it is easy also. Like first video, I just given that idea only. So vanadium, it is 3 plus, right? Vanadium atomic number. Vanadium atomic number, it is what it is, 21. So electronic configuration, 21 means electronic configuration. What you will go for it here? 21. No, here electronic configuration argon 3d1, right? Argon 3d1. So minus 3 electrons. So that means no unpaired electrons. No unpaired. unpaired electrons. So if you write 1s2, 2s2 like that, you will come to know. So this is 3d1, so starting of that. And titanium 2 plus, titanium 2 plus. So titanium, what it is, vanadium next to titanium, it is argon. This is 22, right? So 3d2. So here minus 2, no. So that here also you will not find any unpaired electrons. And the next one, what it is, nickel. Nickel 2 plus. So here 28, atomic number 28. I just round up this. So here argon, 3d8. 3d8 means here minus 2, no? 3d8. Okay, 3 minus 2, no? So 8 only. So, but 8 means here what it is when we are going for that electronic configuration. 1, 2, 3, 4, and 5, 3d8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So two unpaired electrons. But in the question, what they are asking, it is maximum 3, magnetic moment maximum 3 electrons and can form high spin. Actually, here nickel it is low spin only, and moreover, what it is unpaired electron it is 2 only, so it is more than 3 only they are asking. So this will not be applicable. And the next one, what it is, iron. Iron it is 26. So 26 it is what it is. How many electrons in that? Unpaired electron. So this is 2 plus. Of course, this is high spin, but 2 electrons only is there in that. Okay, now here what it is 26 and argon 3d6. So 3d6 means here what it is 1, 2, 3, 4, 5. Okay, now how many unpaired electrons are there? 1, 2, 3, 4, 5, and 6. Here minus 2, no, already minus 2, 3, 4s2, 3d6, no. So 2 electrons have gone, so 3d6 only. So how many unpaired electrons are there? 4 unpaired electrons are there. 4 unpaired electrons. 4 unpaired electrons. So 4 unpaired electrons means naturally this is possible because maximum 3. Okay, now next one what it is? Here cobalt. Cobalt 2 plus, right? So cobalt 2 plus means here atomic number 28. So 28 means argon or 27, sorry. This is 27. 27. 27 argon 3d7. It's minus 2 also. So you will get what it is. How many electrons in that? 1, 2, 3, 4, and 5. So you will be getting what it is 1, 2, 3, 4, 5. Not this one. And 6, 7. Okay, so only unpaired electrons 3. Now 5 rooms only. No, 1, 2, 3, 4, 5. This is extra I have drawn. Okay, so 3 unpaired electrons. So 3 unpaired electrons. So 3 unpaired electrons means 3 plus 4. 7 unpaired electrons are there. Moreover, cobalt and iron, it is octahedral complexes. Octahedral complex. Why? Because it is having high spin complex. So there is octahedral complex. How many unpaired electrons are there? There are 7 unpaired electrons. Right? Hope you got the clarity. Now this is actually option they will not give. This is integer type. So 7 unpaired electrons are there, right? I hope you got the clarity. Come on, let's go to the next question. The next question, here nitrobenzene reacts with bromine with iron. Okay, next one, SN bar HCl, that is Stephen's reaction. And the next one, reduction, Stephen's reduction. And pH, it is neutralization, neutral solution. And Br2H2O. And yeah, bromine with water. NaNO2 plus HCl, that is nitrosonium, that is actually this is diazotization. And CuBr. Okay, CuBr with heating. Okay, Gatterman scotch. Okay, come on. Let us check. This is like puzzle. It's interesting also. Come on, let us go one by one. And the major product, number of bromine atoms present in the major product. Okay, let us check. It is really interesting question. Okay, so the first one, what it is? Nitrobenzene. Nitrobenzene, when it is reacts with bromine, it is actually ferric bromide, right? NO2. So that is meta-directing group. Br2 bar Fe. So this is ferric. So naturally you will get meta-directing group. Meta-directing group means what it is? You will get what it is here, bromine will be present, and then here NO2 as it is. NO2 will not affect, NO2 will be present. And the next one, what it is? Stephen's reduction. So SN bar HCl. SN bar HCl, it is a Stephen's reduction that already you have learned, right? So Stephen's reduction. So nitro group will be affected. Nitro group will be converted to amino group. So you will get aniline. Okay, metabromo aniline you will be getting. So here NH2 you will be getting. Here bromine as it is. Okay. Now next one, what it is? The next one, it is what it is? A bromine with water. pH neutralization, it is H plus H, what it is? HOH only. So that is directly we can go for Br2 H2O, bromine with water. So bromine with water means generally it is actually 2,4,6 tribromoaniline, like you will be getting. Okay, so you will be getting it as aniline, it is as it is will be there, and here aniline, and 2, 4, 6 bromine will be present, Br and Br. Of course, meta group it is present. No, that also will be available here. It will not go anywhere. It will be available here only. Right. So 2,4,6 bromine as well as this bromine, meta bromine also will be present. And the next one, what it is here, NaNO2, right? NaNO2, diazotization. Okay, HCl. So diazonium chloride you'll be getting. So aniline, I mean NH2 group converted to diazonium chloride. Okay. So you'll be getting what it is, diazonium chloride. Aniline point it will be affect, and you will get N triple bond N Cl. So you will get plus and here minus, and here 2, 4, 6, and here Br. So Br, 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 and Br. Okay, now the last one, what it is, copper bromide, that is CuBr. CuBr, right? CuBr while heating. So you'll be that what it is, aniline, that is diazonium chloride, which will convert into bromine. So because Br is there, no, so you will be getting Br over here. So this diazonium chloride will be changing into Br. And 2,4,6, of course, it will be available Br, Br, and Br, not Br. So meta bromide. So this is again meta position, it is available. So how many bromine atom is present? This is the major product. This is actually major product, right? So major product, how many bromine atoms are available? There are 1, 2, 3, 4, and 5. So there are 5 bromine atoms are available. So 5 bromine atoms, all right, you got it. Yeah, so as we observe all these questions, actually organic questions are very easier than inorganic and physical. Inorganic second category you can give. First category, all the physical questions depth level they are asking, so better be thorough the physical chemistry. Yeah, and thank you for watching, and thanks, you have spent the valuable time and you have watched this. Thank you so much. Thanks for your great support.